So here we go. Welcome everyone, and I kindly ask you to keep your microphone off during the session, so we don't hear any echo or noise in the background. And the session will last less than an hour. I think a little over half an hour, so won't take that much. And at the end of the session, we will have time for your questions, if you have some. And of course, you can send us questions via email later on. But if you want to chat with us, I see also some of my colleagues are connected, so we can answer those questions in real time. And if you can make until the end, the session is being recorded and will be published on our website and YouTube channel. So let's start. I'm Matteo Bagattini, for those who don't know me. I work for Sant'Ambrogio since 29, and I work as a developer, and I make some training and customer service. You can find me on LinkedIn and reach me by email. And of course, Sant'Ambrogio Servizi Industriali has been founded by Fernando Lidonici in Milan over 30 years ago. And of course, we produce software, something you know us for. And we are also an engineering firm, making mechanical and thermal calculation, as well as finite element analysis. And also the company profile is available on LinkedIn. Let's see what we are going to see today. We have a presentation of our updates for the 2021 version that is being published during these days. We will have a little insight of what's cooking up for the near future. And as I said, we will have some space and time for your questions and answers. I start with the NextGen 2021 installation, and the first news is that since halfway through 2020, the software can now run in a remote desktop session. This can help you if you have your computer in the office running NextGen with its license. You can now remotely connect to your desktop from home if you work from home for the COVID spread of this year and last year. And so now we let you use your software and be productive also from home without any more limitation. Some people had problems running the 2021 version because they said that the program hasn't been updated, but I would like to remind you that the installation is side by side with the previous next versions. So if you have NextGen 2020 on your machine, the 2021 version will be installed side by side. You need to run the new icon. So if you had an icon on your desktop running the 2020 version, you need to also create a new one for the 2021. Otherwise, you won't see any news, any new update in the software. And also remember to set up your antivirus, because some customers are having some issues running the new version. This is due to the fact that probably if the antivirus has been set up previously, the exclusion for the folder was only for the NextGen 2020 version. But our suggestion is to include the entire path that I'm showing you here in the antivirus exclusions, so you won't have any problem now and for the future versions. And also we introduced a new function inside our Sant'Ambrogio License Manager, which is the program that you can run separately from NextGen that manages your license. And from time to time, people if your computer shuts down unexpectedly, you may run into this unable to start the configuration system or unhandled exception as soon as you run the software. It was previously solved manually by doing some intervention on specific folders, but we added a button in our license manager then let you reset the software default values. This only resets the values the position of the windows or some recent paths that has been used. It doesn't affect any project that you have or custom database like materials, etc. It's only aesthetics, and it can be reset safely, and this helps when you have this kind of errors as soon as you started the software. Okay, let's dive into the user interface updates. Specifically, I would like to focus on two features. The new thickness under tolerance input system that has been overhauled during 2020, and the desktop view improvements. I would like to run directly the demo so I can show you what I'm talking about. So this is a complete item. It's an heat exchanger, and it's ASME Division 1. So if I switch to the desktop view now, I have a more complete view of my components. The components I have in the 3D view, I can see them as icons, but we also added some columns helping you to identify where you have issues, like if you have the wrong under tolerance or wrong corrosion considered, or if you want to check the joint efficiency. For instance, if you have a 0.85 under tolerance in your components, you would like to check if the joint efficiency for heads is set to 1, because it's one thing that can be easily forgotten. And also this list can be printed by clicking this button, and you can print on paper and use it as a checklist to make a global check of your project. If you have any suggestion for columns that we can add in this view, please share. The columns can be configured by selecting columns. Also, for example, if I don't have the external pressure, I can omit these columns. Okay, and this also affects the print of the same table. So I think that this is a good way to use the desktop view, which is usually used to design components that are unbundled from the 3D view. But in this case, it's an helpful overview of your project. Also can be used to check the materials if they are congruent. And again, I was talking about the under tolerance, the new thickness under tolerance system. Previously, we were asking you to input an under tolerance in millimeters. That is the same thing that I have here in a cylindrical shell. So I was able to input the under tolerance, say 1 millimeter. Now we have also this list here that can be changed to select the under tolerance method. For example, if you want to input the percentage of under tolerance instead of the absolute value, you can do it. This is automatically set for nozzles. For instance, I'm adding a nozzle now. I select a pipe from the database, let's say 2 inches. And you see here that the under tolerance method switched to percentage, and the under tolerance percentage is set here. And as soon as you have a calculation, let's set values. Oh, perfect. I'm changing the temperature here to make the calculation. And as I was saying, as soon as you have the calculation done, the under tolerance, of course, in the calculation is still being used as an absolute value, but the software asks you for the percentage. This was previously done, but as soon as you change the dimension of the pipe, you needed to remember to change the value, because it was only calculated the first time that you selected the pipe from the database. So now it's kept on sync. This is more useful in an EN context, like this item, which is EN, because the EN context also shows you an extended list of under tolerance methods that are according to all these standards. And when you select a pipe from the database, you can select the EN 10216, and we are planning to add also the 217. When you select a pipe, it automatically switches to the appropriate norm. You can also use plates according to EN 10029. And we are planning to extend this list to more standards. So you don't have to input like previously the absolute value and make a manual calculation of these under tolerances, because the software does that for you. Okay, our slides. Now, what's new in EN 13445? We're still waiting for the next edition of the norm to be published, and from what we know, it should come this year. So it's expected to be edition 2021. And we added the pneumatic test, which was previously missing, according to chapter 10.2.3.4. We added the calculation of non-circular flat bolted ends, and this goes along with some new addition that we are still making to the software that will let you calculate non-circular bolted flanges along with the ends. And we added the optional validation of flanges, flange welds, according to the table A7. Let's see it in action. Okay, we have our EN model here. As I said, we added the pneumatic test, and under item properties, which can be also found here, under test, we previously had only the hydrostatic or none. Now we have pneumatic and the combination of hydrostatic and pneumatic. So you can enable that and make the test like that. And as I said, we added the bolted non-circular covers. They can only be added as additional components for the time being. So you need to go in the desktop view and add from here a bolted flat cover. As soon as you add it, you can now see, I think it's in geometry exactly, the non-circular shape checkbox. This was already available for welded covers. Now we added for bolted covers too. And from the printout, we see the reference, and we also see that a portion of the calculation is made according to PD PD norm, the English norm, and we are working to add the rectangular flanges calculation too, that will couple with this blind flanges, and again according to the PD norm. And let's see what we also have for the EN. In the flanges calculation, we added an optional wells check. So you can now, this is not mandatory, so you normally see the check like this. If you enable that, you can select a joint type from the list. There are several types, and you can input the well size, and the software makes the calculation to check if the requirements of table A7 is fulfilled. Okay. Okay, let's move on to AD 2000, where we added, or we updated the calculation of the stiffener rings according to the January 2020 edition of the norm. And we also updated the behavior of materials for low temperatures, again, according to W10, which was updated last January, or the January of the last year. And now, this is quite important. We added the ability to select the yield strength to base the allowable calculation for forged austenitic steels. Let's see where it is. Okay, this is a flange made in AD 2000. And here, under General, you can now choose the yield strength for allowable stress calculation. This is automatic by default, but you can force the use of RP 0.2 or RP1. You can see the result of the calculation here. Now we have, let's use RP 0.2, and we have 37 millimeters. If we based on RP1, we're down to 32.93 millimeters. So it was previously made automatically by the software, this assumption, but it's not always the best one. So you can, since the norm allows it, you can now select it manually and see what's best for you. Okay, close. The other two updates are only say something in the norm that has been updated, and we received those updates. We have some new things in VSR, which is the Italian norm. I think that probably most of you don't use that, but I will run through them quickly. And there's also one thing that I would like to show you, because it will become relevant in the near future. So we added a calculation of site class, and this can be also extended to other codes if it may be interesting for you. If that's the case, please let us know. And we added the pneumatic test also here, like in the EN. And since from time to time the allowable stress, the stress ratio used by the norm can be the highest instead of the lowest, we highlighted this assumption whenever it works. And we enable the torque calculation as usual according to ASME PCC1, and we added some materials for requalification of old vessels from these Italian norms. I won't show you the demo for this one, but there's one thing that I would like to show. And we also added this checkbox because all the flanges in the Italian norm should be calculated by code, but customers now can select this option and let the software use the rating for standard flanges instead of calculating them all. And this is the important update that we made. We are test driving it in the Italian code, but we plan to extend it to the European code, and we will see if we are able to extend also to the ASME code. And that is the equations in the calculation report that can now be printed in numeric format. I would like to show you. I think I closed NextGen. Let's see it in action. We are already working to the European EN 13445 version of this new feature. And every time you print the calculation report, now you have this option here, print numeric equations, with a little help explaining you what does it mean. Click OK. Okay, the calculation report in this case is a little bit different. You have these lines, otherwise you won't be able to tell one line from another, because we have these double-decker equations now, and we are planning to use also to let the user also select a combination of configuration if you want only the numeric, only the symbolic equations. But this is quite interesting feature also because some customers that are coming from different softwares are used to have the values of their equation displayed in the calculation report. So it is now possible to do this thing, and also, of course, check the calculation more easily instead of going through the values that you have above and see what the value of each symbol is at the moment. And again, this is a feature that is available for the moment only in the Italian code, but it will be extended soon to other calculation codes. Okay, I think it's here. Okay, we are. We have an update for the PD that involves all the European codes. There is a note in the PED guidelines G06 and G08 that said that from time to time the bolts material should be considered when determining the lowest stress ratio. Particularly, a bolt is not considered to be a main pressure-bearing part unless its failure will result in a sudden discharge of pressure energy. So if you fall into one of these cases, where your bolts are needed to keep the pressure inside your vessel, because otherwise they would result in a sudden discharge, then in your flanges you can now include the bolt material in the determination of the minimum stress ratio for the test pressure. So this is optional. You have to opt in for this behavior, but keep in mind that the PD say this note in these guidelines, and if you want to apply for this behavior, you need to check this option inside your flanges and let your bolting material be included inside the determination of the lowest stress ratio. Okay, let's move on to ASME Division 1. We are also test driving this new feature in for a single calculation code, because we want to receive some feedback about this specific feature, and then we will expand to other codes like the EN code, for instance. And so we added the support for cladding and weld overlay inside the calculation of vessels, and let's see it in action. So this is division 1. Okay, if you go to see your item properties, you have a new category here, which is lining. We moved also the insulation inside the lining. So it was previously in a standalone category, but we moved here because it's more appropriate. And we have now this option to include the cladding and weld overlay, to define for the whole vessel the cladding and the weld overlay. First thing to consider is that the cladding can contribute to the base metal resistance. That is the whole point of this addition, is to be able to consider the cladding material as resistant to the pressure, because otherwise we can do like we did before and consider this lining material as corrosion. But the good thing is that part of this material can withstand the pressure, and so we need to consider it. This is optional. You can opt out from this option. You can select the cladding material from here, and the base cladding thickness and weld overlay thickness. This is used as the design conditions, as a blueprint for the new components, but can also be changed later on. And let's see both in action. Okay, we have a cylindrical shell here, and the lining category has been added here, and we can select the lining type if we want cladding or weld overlay. The software tries to infer which is the best one for your pressure part, but you can always change. The lining thickness uses the default value that has been defined for the whole vessel, but you can change it here. And let's see in the calculation report how it goes. Of course, we have a recap of our input values here. We are saying that the cladding contributes to the base metal resistance, and for this we have the determination of the cladding effective thickness, which is a function of the stress ratio between the base metal and the cladding metal. So we determine a thickness reduction, which is the portion of the cladding that is unable to withstand the pressure, and we add it to the corrosion allowance. So we sum the corrosion allowance with the portion of the cladding thickness that is not effective. Then all the formulas stays the same because C has been redefined to include the cladding thickness. This only works for cladding because we can't select a welding material because we don't have basically the mechanical characteristics of the welding material. And in the case of flanges, for instance, the lining type can be set to weld overlay, and the lining thickness is again the one that we selected for globally for the item. But in this case, we don't have a calculation of an effective thickness because all the thickness that we are adding as weld overlay is ineffective and is being removed as a wall corrosion. But it's interesting to have it separate in your calculation report. So this is the second feature that I have showed you that has been added for a single calculation code, but again, we are planning to extend to more calculation codes. We are gathering some feedback on this feature specifically. And for instance, we had a feedback from a customer asking to consider or not this cladding and weld overlay material weight in the calculation of the load combination for the structural support. And we are working to also consider those materials in the weights of the vessel. Let's dive into the WRC and supports changes. So we added an option to keep the WRC loads on a support in sync with the support calculation. This has been added because previously there was a button to read the loads from a support, but if you made changes to the whole structure, like adding weight or removing weight, the loads for the WRC on the support stayed on a previous state. Now it is possible to check and keep those loads in sync. We can now again add legs made of pipes from B36. We can now select to use the column structural analysis to calculate legs and skirts. I'll show you how. The foundation bolts calculation temperature can now be set within a load combination and changed from 20 degrees to whatever you need. This is a very small change, but it was annoying, and the forces and moments that were shown in the WRC loads in the component window were different from those shown on the calculation report in terms of directions, and so we made that congruent. And now the WRC loads can be used on flanges as external loads, so consider on flanges. Them in action. Okay, the first thing that I told you was that we added in WRC a checkbox here, keep WRC in sync with support loads. It can be set, and you see that we have this set of loads here. Previously, you could read components load to fill these values. Now we have I have put a weight here, and I want to increase that weight. And if I go back to the legs, okay, of course, it can't withstand the load, but also the loads here on the attachment to the shell has been updated automatically. So this is quite handy. Then here in the item properties under loads, okay, for our customers that have the calculation of the structural analysis as part of their license, they can now use the result of the structural analysis for skirts and legs calculation. What does it mean? It means that if you don't have this option, because maybe you don't have the structural analysis of the column, if you made a calculation of the legs, for each load combination, you have a determination of the loads acting on the leg and the foundation loads. If you have in your license here loads, the structural analysis as part of your license, you can use those results to calculate your legs. This also works for skirts. And if we make the whole calculation of our vertical vessel, of course, this is a very short vessel, so you don't have any big difference, but for large columns can make a difference. Here we have the column structural analysis. So we start from the top and go down to the bottom and see all the loads acting on each part of our column. And the results of this analysis are now fed into the legs calculation. We don't have the loads calculation anymore in our legs calculation, and we just use the values determined by the structural analysis. This also helps if you had previously noticed that you had the structural analysis giving you some results and the legs calculation giving you slightly different result. This happens because the structural analysis consider the vessel as a whole, so it's more precise in a way. Otherwise, the legs calculation or the skirts calculation alone consider only the global weight localized on the center of gravity of your vessel. Okay, let's see what we had. Also, foundation bolts calculation temperature. Yes, you can set from the load combination. So you can go in any of your load combinations, click edit, and now you can set the calculation temperature for the anchor bolts. And okay, this is not very, this is the image I was referring to. So these forces and moments are now in sync with those shown in the calculation report. I think it's in the summary. Let's see the summary. Okay, these were the images I was referring to. So there is no more confusion in this area. And finally, I think that we have, yes, in flanges, this is a nozzle where I defined WRC loads. Here you can see them. And now in the flange calculation, if I want to, I can, in external loads, I can use WRC loads as external loads for my flange. So I have an equivalent pressure considered in the calculation of the flange, which is based on the WRC loads. We are also working on visual clues to show you where a flange or nozzle has external forces applied to. So this could be, this will be probably available in the upcoming version of NextGen, so 2021.1, and you should see visual clues around your nozzles where you have defined WRC. Okay, we have some MISC news. Let's see. Okay, we improved the calculation of some components weights. This is a typo here. So the weight of some components has been improved in terms of precision. We included the reinforcement pads for legs. We fine-tuned the calculation of flanges, specifically reverse flanges. That was a little bit off. And we also included an estimation of bolts and nuts weight. And I'll show you how to include that, because by default it's not included in the calculation of the weight of the flange. Now under tolerance can be set on tube sheet flanges, long welding neck, floating and blind flanges. The material is now split between the heat exchanger sites, because those sites have different temperatures quite often, and so the characteristics calculated are now split between those two sites. The 3D models can be exported in BRAP format, and again, I'll show you how to do that. We added the calculation of reinforced expansion joints according to ASME, and this feature can be helpful in some context for those customers that are making the channel of the heat exchanger made from only one component. So we added the ability to add in a BEU, for instance, heat exchanger. You can select the bonnet as a flat bolted cover, sorry, and so you can model this type of heat exchangers by adding only the cover, which is bolted to the tube sheet, and then add the nozzles. Let's see an example of that. Okay, here it is. This is what I was talking about. In your bonnet type, now you have bolted flat cover, which creates this type of heat exchanger. And now also for this type of covers, the thicknesses here, you can have a peripheral thickness, which is larger than the center thickness. If you have this type of scenario, you input the center thickness as the thinner part of your cover, and the peripheral thickness as the thickness of the bolted section of your cover. Now you're good to go. Also, we had okay, the weights. Let's have a flange here. Under weights, you can include an estimation of the bolt weight here. It is then considered as the global weight of the bolts, and you find it under weights. Okay, it is split between the welding neck flange and the welding neck flange bolts. This is an estimation because we don't have all the values needed to make an accurate calculation of those weights, but I think it is a good estimation of the real weight of the bolts and nuts. Okay. Okay, the export of models in BRAP format is a global option that can be set under Tools and Options. Appearance, you can use BRAP models here. So when you export model here for a 3D application, the format of the 3D models is BRAP. And okay, we have expansion joint according to ASME. And finally, when you print an heat exchanger calculation report in the, let's see where it is, materials. Okay, the materials properties summary is now split between the shell side and the tube side materials, each one with its own calculation temperature. Okay. Okay, that's a wrap for what concerns the a selection of what has been added to the software. Of course, there is a long list of new features and enhancements and bug fixes that can be found on our website, or if you want, you can reach it from here, history of changes. You go to our website and there it is, the whole change log for this version. Let's see what we are working on, and As I previously said, some of the new features has been added only on specific codes, but we want to extend them to others. So expect to see the numeric equations also in EN. And we are still working on the cladding and weld overlay support in terms of ASME Division 1. Once we are satisfied about the implementation in ASME Division 1, I think we will extend starting from EN 13445. We are working on improvements on the 3D model export because this is something that is quite often asked by our customers. And so we are working on that. And also, if you have feedback in this area, please share with us, because we need to understand how this export works on different scenarios, different softwares for 3D modeling. As I said, there will be visual feedback showing where forces and moments are applied to an attachment. We are working along with the gasketdata.org platform to include their data, or better, to make a live connection between NextGen and gasketdata.org. And this will be very helpful when calculating flanges according to EN 1591, because most of the calculation depends. This also for Annex G. Most of the calculation depends on the characteristics of your gaskets. So you need to use a very specific gasket, and gasketdata.org collects data from the manufacturer of these gaskets. So it can be very helpful to have them inside the software. Yes, also the non-circular flanges according to PD code will be available in all calculation codes. This will be a special feature, so for all the calculation codes. And you will see the ability to define the welding lines for shells and heads, and so it will be helpful to position your nozzles in this case. And we are also working on a website dedicated to NextGen, and it will be full of help articles, videos. You will have the ability to manage your license from there, download the software validation samples, and we would like to create a hub of information about NextGen on a specific website that will be available along with our company website. As always, your feedback is very precious, so please share with us what you'd like to see NextGen, because some of the features that we implement are based on the feedback that we received from our customers. So feel free to share that, and even if we don't give you an immediate answer in terms of implementation, keep in mind that we collect all these feedbacks, and once they reach a certain critical point, like a feature that has been asked from different customers, then we review that and add to the software. So your feedback is very important and taken into consideration.